So I want to go from here to here and then equalize both sides of this back. Make sense? Cool. All right. So what is electricity? From, don't worry about the positive and negative. From where to where? From the side with more electrons to the side with less electrons. Make sense? All right. How do we measure how do we measure batteries? Amps. Well, I only gave you some of the answers. What's that?
I don't know how to experiment, but I just feel like on the read or something, but I
And just to prove that electrons aren't on the negative side, you can wet your fingers and touch the negative side. Is anything going to happen to you? Why? What if I wet my fingers and touch the positive side? We're having fun now, aren't we? Batteries are measured in amp hours. This is a 12-volt battery with 15.3 amp hours. 12 volts, 18 for the 20 amps. I don't know which one this is. Looks like they have two different models.
You can look on the back and it'll show that.
It does?
So over time, the amount of amp hours the battery has decreases because it gets obviously damaged or hit, and it breaks apart the magnets inside that allow it to hold a higher capacity. So that's the max amount of amp hours that that battery can have.
Good. What is an amp hour?
Here, there's amp and there's hour. What do you think those mean? The amount of hours that a system can push out a certain amount of amps.
This guy is going to be
You guys are be playing now.
volts. Make sense? At 12 volts, this guy is 12. Let's say this guy is actually 6 volts. Got it? So this guy is 6 volts. And I have 18 amps that I can push out over 1 hour constantly. So I can push 18 amps for a full hour. Amps are what I'm going to push. So I'm going to push these dog bone things. These are called amps. And amps are how many amps I can push through a pipe. What's the pipe? What might a pipe be? Got it. I can push through this wire in an hour. And at 6 volts, I can push this many amps. Now, if I wanted to double this and do 12 volts, now I get a second guy pushing. What should I be able to do? Push more amps. Inside my battery, I've got chemistry. These are lead acid batteries. This has a maximum threshold in this configuration. That determines the size of this opening, the size of the pipe. If I have more amp hours, more different chemistry, like a lithium-ion battery, now I might be able to push 3 at a time. Right? Make sense? So voltage is how much I can push, and amperage is how hard I can push. And it has to do with the electrons and the chemistry of that. Yeah? Why is this important to you? Eva, why do you think voltage and amperage is important to robotics?
Because our motors need a certain capacity in order to function mechanism.
What do I do now?
What might happen if we don't manage it?
What do I do now? Daddy.
Might die, so we might use up all the power in the battery.
Daddy, play that dinosaur.
What's a brownout?
Push out more.
Incorrect. Anybody else want to guess what a brownout is? Nope. That's a runaway.
You do have an impact.
You're close. What's the critical item in a brownout? Let's say for a moment, your heart was pumping blood, but it just didn't have enough pressure to pump the blood to your head. Yeah? What would happen to your body? I got plenty for your lungs and plenty for the heart and legs and feet, so I can like do this all day, but if it's not getting to my brain, I might not die. That's only if it like stops going forever, because as soon as I fall, I should have enough, pressure to now go to my head because it's not horizontal, right? Yeah, I think. I slow down temporarily. I bring this up because a brownout is when you lose amperage to your Rio or your brain, in essence, of the robot, or your communication device, your radio. If you lose the amperage to keep that fully powered and it turns off for a moment, brownout. Everything else is fine. Your robot has plenty of power. You just use too much in one moment that you reduced your total amperage available for your brain and your radio, lost communication, or your robot turned off and has to reset. It takes about 30 seconds. What happens to your body when you're driving or watching that match? Anybody remember? So your soul is going to start to compress, and you're going to feel sadness and frustration, and it's going to start to ooze down your leg and out your shoe as you watch the other 5 robots on that match continue to move, and your robot sitting there doing nothing, and the time is continuing to tick on because it's only 5 seconds that your robot stopped moving. And now it's 10 seconds, and you're like, this is horrible, I give up, why did I do robotics? And then at 30 seconds, you're like, yes, it's moving again! That's never happened to you?
Usually it doesn't move again.
Well, if it never moves again, then you just start to you go through the 5 stages of grief before that match ends. That's a different level.
What?
Alright, so voltage and amperage are very important because my battery has a limited amount. I can't put a system on, sorry, that's any more than 12 volts. I can't expect how much the push go up. Unless I put a transformer on, we're not going to go through that. And I only have 18 amp hours. So that means I can push 18 amps for 60 minutes. Our matches last for 60 minutes?
No.
So 18, 60. So then I've got 36 for 30. And I've got 72 for 15. This is amperage, minutes. And I've got 144 for 7.5. And I've got 288 for 0.75. And how long does a match last for? 2.5. So I could probably get, let's say 2.5, I'm not doing the exact math, but maybe like 30? Is it the guess? Do I get 330 out of my battery? That means if I pull 330 amps, I can last for roughly 2.5 minutes. Do I actually get to pull 330 amps? Why? Does anybody know how efficient a car is? If I put a gallon of fuel in with a certain amount of caloric energy in that fuel, does my car use 100% of that fuel to move forward? How efficient is my car? If I were to say 12%, does that ring any bells with anybody? Oh my gosh, I guess you can play a game. So, we can't assume this. If we do, we're screwed. Because that's assuming this is the perfect battery, and that I have no inefficiency in my system. Bad idea. So the going rate is you don't want to use any more than 240 amps at any one time, maximum. That's kind of ultimate for this battery, based on all the potential issues we might find with batteries and the inefficiencies we might have in our system. Make sense? It's well below 330, so it should be able to last 2 minutes. Make sense? All right. Keep 240 in your head. We're going to come back to that because now we're going to go through the electrical system and talk about where all this power goes. And we'll get back to 240 in a second. All right. What makes up an electric system? Who was there for my overview video or overview presentation? What are the 3 major things in an electrical system? If I were to say power, and if I were to slap you right now, would you feel it? Why would you feel it?
Force.
No,
Feedback.
You have a nervous system. It's like, I was just slapped. Why does this man just slap me? Power is what?
Does this need to be powered? Energy?
Yeah, that's the 240 amps. That's the 12 volts. Control is what? Arm, shoot out. Arm, hold up. It's the what?
How you use that energy? Nervous system?
Control is what? It's the signals. Go do X, right? Go use this power in this way. And then what's feedback?
All we receive from it?
Oh, that's too early.
It's, is my arm going out? Yes. Is my arm still going out? Yes. Is my arm going out? Yes. Is my arm going out? No. Have I reached full extension? Yes. Do I want to continue to try my muscles to like try and extend more? No. I don't even know what that would do in this position. But if it was like here and I was just trying to scratch, you know, like above my eye, and I'm like, oh, I've got contact. I got feedback from the fingertips. I got feedback from my muscle system. I got feedback from my face. I want to ignore all that and just jam my entire face into my eyeball, right? That's like bad feedback, right? I didn't get all that feedback, and so I just kept going. And I don't know what I would do in that situation. Why did you put your whole hand in your face?
Okay.
I didn't have the right feedback in my body. Feedback is critically important, right? You can't walk without feedback. There's, I think
Wi-Fi
I
in
told
the
some
hall?
of you guys who are at the other one. So my wife studies one. There's a disease, I can't remember what the name of it is. Everybody do a quick exercise. Close your eyes. Put your arms out to the sides of your body. All right, fold your arms 90 degrees. Now keep your arms folded 90 degrees and bend your shoulders until your fingers touch your head. Bend your shoulders
Touch
until
your head.
keep your arms at 90 degrees and bend your shoulders until your fingers touch your head. All right, open your eyes. All right, you're able, some of you were able, to do this without looking at your arms, right? Whereas if I could do it while looking at my arms, try it now looking. Yeah, we can all do it pretty well. We can all look. Because that's an additional feedback mechanism, right? Probably our primary feedback mechanism if you still have the ability to see. There are people, so you were able to bend your arms 90 degrees because you could feel it. Your muscles are telling you, hey, you're at 90 degrees. You can do this way too.
Touch your fingers with your eyes closed.
If you do that without your eyes closed, you might miss, right? Because your feedback mechanisms in your muscles alone are not precise enough to know, hey, I'm touching my 2 fingers tips. I need to add the second feedback mechanism, which is my cameras or my eyeballs. There's a disease, for example, that I don't get muscle-based feedback. Those people can't walk without walking at their feet. They have to walk like this because this is the only feedback mechanism they have in that body. They don't have the mechanism for getting the muscle feedback from our legs like most people do. Make sense? All right. So, we're gonna first talk about the power system. Make sense? Battery. Yay. All right. Next thing is what's called a breaker. What does a breaker do?
Controls, or limits the amount of energy that can flow out. Makes it so if any,
It does.
any part of the robot that is using too much electricity, it'll stop electricity from flowing through it.
Does a breaker care about the voltage?
No.
Does a breaker care about the amperage?
Yes.
What's the maximum on our breaker?
240.
Oh, isn't that a kind of a cool number? Right? Why would you not want to use any more than 240?
Because you can't, so we don't drive.
What happens if you pop a breaker?
You use it a lot.
Who here's ever blown a breaker in the house? Does it come back on automatically? What do you have to go do?
You have to switch it for a new one.
What happens to your robot for the rest of that match? Nothing! It's dead! 240 amps. It's also our primary on-off switch. It's our safety mechanism. If the robot is doing something you don't want to do, hit that. I'm going to give you an example of why a breaker is a good thing. In college, I built my first robot for robot players. We were really excited when we got it partially assembled and put on our 20-inch saw blade. We had just enough code, we just wanted to see if the thing would work, to spin the saw blade. We had some leftover code because we were testing the drivetrain the week earlier to see if the drivetrain would work. And we were spinning the drivetrain. Lo and behold, everything worked fine. We had no off switch. We had no remote control. It now has a 20-inch blade that's spinning at 14,000 RPM or some crap like that. We all jumped on desks. This thing's spinning around on the ground. We start throwing anything we can reach at it. We're like doing the floor is lava to stay away from the robot and like trying to whack it with a broom. We didn't have one of these. We should have, but we didn't. Don't do what we did. Finally, somebody hit it with the broom. Like, I think they disconnected the power because we didn't have, it was all fully hardwired. There was no like on-off switch. So we were stupid. Like, oh yeah, it works. On-off switch, it's a major part of first safety. If the robot is doing something wrong, if someone is stuck in the robot, what do you want to do?
Someone
Yeah.
is stuck in the robot?
We've had a year where someone was stuck in the robot.
Wait,
Is it a big one?
If your finger is caught in chain, for example, do you want to pull your hand out of the chain? Do you want to scream and tell someone to turn the robot off?
Yes.
Are you going to be able to pull your hand out? Is your hand going to feel wonderful? Yes. Does everybody know what red indicating fluid is?
Blood?
Yes, we all have it. We don't want to see it on our robot. Does everybody know what brown indicating fluid is?
Blood that has turned, like weighted blood?
No, it comes out the other side. Absolutely do not want to see that on the robot. We don't want to see that in your pants either. No one has
Someone
pooped
gets
themselves
scared.
here.
When some people get scared, my friend, it goes.
Alright, but the only thing this stops is electrical power. We're going to go over a system tomorrow called pneumatics. This does not stop pneumatics. So if you're stuck in pneumatics, this breaker does nothing for you. We're going to talk about how we have to turn that off as well. Alright, so I've got a breaker, 240 amps. Then I've got a power distribution board. It's called PDB.
It's PDH now. Power
PDH.
Distribution Hub.
Power distribution hub, because Rev likes to market things. Alright, power distribution. Yeah?
It tells you where power needs to go.
Yeah.
For the robot.
What's the equivalent inside your body?
Brain. Heart.
Sort of.
Nervous system.
What kind of power source does our body run on?
Oh.
Your heart.
Oh, food. Food is the device. My heart is just blood.
Do we have a battery in our body?
Our heart.
Our heart sends power? Are we hydraulic system? Is it pumping to a pressure and then that's what's using pressure to move my arm?
Tell, is it your, no, your stomach?
I forgot the question.
Your stomach.
I don't know, it tells you.
Your stomach and
It tells you where the food is.
I'll give you a hint. Give us the closest. We eat something. What does our body use?
Glucose.
We're a chemical-based system, right? So our blood is sort of our battery, but it's primarily moving the sugars into the consumption areas, which are your muscles, right? Make sense?
So the heart.
Sort of, but not really.
Wouldn't the blood be the energy? And if we're talking about distribution of energy, the PDA should be the heart.
Yeah.
It's the heart plus the digestive system moving the ATP around your body, right?
I got like everything above the average, everything.
We're a chemical system. Alright. Nonetheless, everybody can say, I ate food, I can now go out and run, right? If I stop eating food, what happens to your body? Hard to move.
How much food do you have in your system beforehand?
Doesn't really matter. After a certain amount of time, you will run out of chemical energy, you will not be able to move. Yeah? What does that do?
I heard that the runners have to eat a big pasta meal because carbohydrates like as a fast energy source.
Yeah, so I'm trying to put as much energy into my muscles as possible. Alright, my PDH, I have my positive, which goes to the 240 amps, comes out to this side of the PDH, and my negative goes directly to my PDH. So which way is electricity going to flow?
From positive.
Got it. My PDH is about distributing power. What systems do I need to distribute power to?
Motors and drivetrain.
One at a time.
Motors and drivetrain.
Alright, so let's start with motors. I have a motor. Do I go right to the motor?
No, you need something to tell, like,
I forgot what they're called, little weight things on the robot. I forgot what they're called.
Your first bird.
Anybody want to help?
The little white things that are just in front of the motors. They're you plug them in.
That's a type of one. She said sparks.
oh, that's a pole.
No, it's because it tells how much. Because if you're plugging it directly into the pH, doesn't it give sometimes too much or too little, and that just is like capacitor or something? I forgot what it is exactly.
So I just plug this right into the motor, and as soon as I hit that breaker, what does this motor do?
Oh,
Right? That's not what I want. What do I want to put in the middle?
something to control the electricity.
Which is called a motor
drive. No, a motor controller.
motor controller.
Oh yeah. Is it the? Was that right? Was it the little white things on the robot?
Yeah, those are a type of motor controller. I'm gonna get two wires, positive. Negative. Nice and simple. From the motor control, I will have power. Because I only have two colors, I will have a motor. And so now when this turns on, this has power, but it's waiting for what? Control. We'll get to control in a second. Alright, so I got a motor. What else do I power? Someone else. Okay, radio.
No, call mom. So you can tell her that we're
Okay, what else? I got you. What else? What? Are there buttons on the robot we need to push? So are you on the power system or the feedback system? Alright, so let's think of power. What else do I need to get power to? What you got?
Radio.
Yep.
Or maybe she's on here. Power is
Spell. Okay, what else? Any guesses? Huh?
Huh?
What you got?
The sensor and the light. Oh.
I can get power to the, what's called the RSL, right? I think? Yeah. Power comes from the Rio, right?
To the RSO, yeah.
Okay, RSL, why do I have the RSL in there?
Oh, so you know what's happening for a while?
Sort of.
If you know it's turned on. You know it's running.
I know it's turned on, and I know if it's
Active.
active. So it's not everybody can see it or hear it, right, running, but maybe I can see that, hey, I probably shouldn't have my hand in the robot right now. Yeah?
A robot that they built years ago had LED lights on it, so maybe like how it illuminates.
All right, illumination.
Wait, what was the name of that purple thing you found on the old robot that McQueen doesn't have? The, you know what I'm talking about.
Sensors out there?
No,
Those are part of the control.
sensors are feedback. No, it's like a little motor control board. Like,
Yeah,
not
feedback,
that.
sensors are feedback. Control. And then the brakes.
Encore.
Yeah, I'm pretty sure, yeah.
What else is on this
There's like a
robot?
purple thing on the bottom.
And then color.
Do I need to get power to my encoders? Or is this part of the feedback system?
Feedback.
Yeah?
What about the, where, to tell where it's going, I forgot what it's called. The,
IMU?
yeah.
Anybody know what an IMU is?
It's something, I forgot what it's called. Huh?
Inertial measurement unit?
No, it's a, yeah, it is an,
Anybody know what that is?
it tells you where you're going, right?
What does your inner ear do when I start spinning you in circles?
Oh, makes it easy.
It tells you
There will be sensors, we'll get to those. Those are part of the feedback loop. But don't let that one go. What else do I have to power on this room? Give you some hints. So, if I have a pneumatic system, I need a pneumatic controller. If I have anything that isn't at 12 volts, remember this is a 12 volt system, I have some devices that are at 5 volts. I have a power breakout board. No, what is it called? Power.
That's the purple thing, I think.
No, that's he's talking about the BRM,
I think power.
or
We'll call it 5 volt power. I can't remember the name of the board right now. All right.
maybe the RP.
I also have a switch. Ethernet. What else do we have on the robot? What's that? No, there's nothing that's sensing. I can't tell you if it's broke or not, except for the fact if I have power. So I guess there is a way to sense it. I take that back. But if I have no power, I'm not sensing anything. So it only senses in one direction. I have a Raspberry Pi in the robot. What else do we have? Yeah?
Cameras.
Cameras. Cameras get power from the 5 volt power, right? And this is a very special type camera, not all cameras. Alright. Do I have just one motor controller and one motor?
No.
So just multiply. Make sense? Alright. I'm gonna write one more motor because when we do control here, I need that motor for that. Actually, I'm gonna do 3 motors. Make sense so far? Yeah. That's just power. Does anybody know how a motor controller works?
I think doesn't use code to like. I've used a Raspberry Pi once. Don't you put code into it so that you can like control when the motor is like gets a certain amount of power depending on how much time you want it?
Sort of. Alright, so I think everybody here has flipped a light switch. Would you guys all consider yourselves expert light switchers? What happens when you flip a light switch?
The lights turn on and off.
So it's a binary circuit. Alright, so I have a relay, which is one type of motor controller. And I send power into this thing, and I can send power out one of two ways. So I can send it out here, or I can send it out here. This is a relay. And the power graph looks like this on a relay. So I'm either nothing, or I'm everything. Right? I don't have any, I can't, this is 100%. This is 0%. That's my power. I either nothing or I have it all in a relay. Make sense? Does anybody have a dimmable light switch in their house? Does it work like this?
No, you have it's a slider sort of.
Alright, so I have an analog motor controller. This is how this works. I have power coming in and I have a range. And based on where I enter that range, so I can have various fidelities, I come out of that. I can do it with a potentiometer, sorta, or I can do it with a resistor in circuit. Depends on the type. And what this allows me to do is I could do that. Here's the dilemma. In this circuit, usually it's a resistor. If I'm pumping 100% of my power through, and I only want 50% of the power to come out the other side, what's happening to the other 50% of the power?
It's going into the system.
It's throwing a resistance. So in my house, where I've got hooked up to a power plant, not that big of a deal. I only have 240 amps. I don't want to throw half of it in the heat. Yeah?
Would you like find a way to split the current into two separate, power two separate things?
No,
That
find a way
would be the smaller one?
Fortunately, you can't. If you wanted to optimize the system and design, you absolutely could. Based on the cost products that we can purchase, not like you're just going to dump in a for them. So what you're not doing. This is the heat curve. And this is the power. Yeah.
Can we have something where like it instead opens it up slightly or something like that?
All right. So inefficient, but it now allows me to get various speeds, right? So not all enough. There's a thing called a digital motor controller. Digital motor controller is solid state. Digital motor controller has in essence, a relay, no power, and it has diodes in a very specific order that it can power and depower. Follow me so far? When you go digital, anybody ever heard of 1 hertz, 2 hertz, 3 hertz? What is that?
It's I only know I have the power microphone, so I don't know.
Frequency.
Frequency. What's our robot run at?
15?
Go ask Gamer real quick, or Zach. See if we can get the official answer. Here's why this is important. Let's say I'm running at 1 hertz, once per second. I'm going to divide this into seconds. 1, digital motor controller, let's say I want to be at 100% power all the time. It will turn on and just stay on for 100% the entire time. Make sense? Let's say I want to only be at 50% power. So here, I'd be at this point where I'd be dumping half my power into heat, half my energy into power. Instead, what a digital circuit says is it'll run 100% power for half your frequency. What is it?
30 hertz.
30 hertz. So this is 30 times a second. And then it'll go 100% of the power, 100% of the power. So that'll give me 50% power. Am I dumping it into heat? So I'm not wasting a ton. Am I mechanically moving something like in a relay? So this has a certain response time that a bunch of diodes don't have, because everything inside the solid state circuit is moving at the speed of light. Make sense? Because they're all electrons. Most efficient form of power motor control. And if I'm doing this at 30 times a second, is it perceptible to you? No. What's the fastest you can see? You're on your phone real quick. One of you look up, what's the frequency that the human eyeball can see? Here, look it up real quick. What's the frequency above which the human eyeball won't notice things?
75.
For the lights, this is 40 to 700. 30 and 60.
30 and 60 hertz?
Yeah.
All right. So I can notice it below 30 hertz?
Yeah.
Really?
Look at it, yeah, it's like 30 minutes, it's like grilled cheese, like it's
Okay.
it's running smooth. You can see the difference.
So we might be able to notice, let's go with that. We might be able to notice if our motor, using a digital motor controller, is having an issue.
No, it's fine. It's right on the
But
numbers.
high probability
Brother, we
you're
have
not
to
gonna
look
be able
at
to.
the numbers.
Alright, so what type of motor controllers do you think we have in our robot?
All of them? That's digital?
Yep. This has not always been the case. This has really only been the last 4 or 5 years. Maybe 6 years.
Don't have a relay to just start the robot, like connected to the power.
That's a breaker, not a relay.
1,
A relay does it automatically.
2,
We were analog for most of our time here. We've been around since 2004, so most of our motor controllers were analog. No, and I'll tell you why. We have smoked ones, but yeah, we'll get there in a moment. Actually, we can do that next. All right. Why was all that important? Because you have to understand how we're using power. If I'm running at 75% power, what percentage of the time am I pulling my amperage? So I could, you asked if I could, when we were talking about the analog, can I potentially use two in parallel at different times to dump heat? The answer was no. But for an entire digital system, Zach's code could say, for the top of every cycle, power these two motors. From the bottom of this the cycle, power these other motors. Still 30 hertz. Make sense? But now my total amperage, I'm not running all 20 motors on my robot at the same time. I'm only running 10 at a time at a cycle. Make sense? So my battery's not getting hit too much. Or less. Alright. Very important. What does a brushless versus a brushed motor mean to you guys? Do you guys know what a motor is? What do you got? Major parts of a motor. One of the two of you look up on the phones. Look up major parts of a motor. I remember some of them. Stator. There's 3 major components.
Rotor, armature, bearings, brushes,
Start slower a little. So stator, rotor.
Armature.
Yeah.
Our bearings, we got the board out.
Perfect.
Brush.
We're really just gonna focus on these three plus the brushes. So, in a motor, I believe the stator's in the outside, right? If you guys are looking at the picture. Stator's on the outside, rotor's on the inside, right?
Yeah.
I'm gonna draw it from the back. Rotor. Stator. Brush. This is a horrible picture of it. I'm trying to make the thing in the center turn using magnetic fields on the outside. Make sense? I want to induce magnetic fields on the inside. And so with a brushless motor, I have these things rubbing the rotor all the time by design. They're usually made out of some type of funky carbon. And that's how I'm inducing the magnetic deltas between these two motors. So it takes less magnetic energy to turn this motor, but overall I've got higher friction. So I'm less efficient overall. Does this make sense? Yes? Then we have brushless motors. Rotor, stator, no brush. It takes more magnetic energy to rotate, but I'm not losing any energy as it rotates because of friction. What type of motors do we use on a rotor? So for a brushless motor, my power might look like this. So this is current, time. And so I will do this. And now for a brushless motor, I'll say this is 30%, and here this is 60%. So I have a higher spike to get it turning, right, than this. So what does this mean every time I use all my motors? Do I have to worry about my amperage the entire time? Or do I just have to manage amperage in that first 2 seconds? And if I'm using my drivetrain, I'm using 8 motors all the time to do different things. So I have to potentially limit, hard limit, and say software limit, amperage limit. I can't go any higher than that. What does that do to my current? If I have a hard limit, now it does this to my curve. It expands, it increases the amount of time and I'm at that limit. And I don't accelerate as fast, but I keep my current usage down. Make sense? All right, here's why this is important. In that drivetrain, I've got 4 drive motors. And I've got 4 turn motors. I can't remember what the max current on the vortexes are, but I want to say my max free speed current on these, or my max current draw is going to be something like, I want to say it was like 90 amps. And on my 550s, it's less. I think it's only about 50. That's the max that the motor can draw. So, what's 4 times 90? 260. Yeah, I'm sorry, I thought you said 260. 360 amps. What happens as soon as I start all 4 of those motors at the same time? Yeah, I just browned out my entire robot. Done. 200. So what do I have to do? Yeah. I have to use hard limits in the software, and I have to be real smart. Maybe I don't start them all at the same time. Maybe I start 2 at the top of the cycle and 2 at the bottom of the cycle. Now I'm only seeing what? Am I below 240? So now, let's say I'm gonna put a max of, let's say, 60 amps, and a max here of 30 amps. Now what am I doing? Now I'm gonna continue to use this, so now I'm at 120 and 60, so now I'm at a total of 180. Because I'm gonna keep them on different cycles. Do you guys know what the breakers are? So we got one breaker here, 240 amps, right? Inside this PDU, I have other breakers. What are the sizes of my breakers? What are my options?
I believe 20, 30, and 40.
20, 30, and 40. Did they tell you the news?
I heard about some flooding, basically.
We may not be in the room this week.
Alright.
That's how it's gonna go.
Alright.
We're doing the basics of electrical.
Nice.
We've gone through our max amperage and how we got there. We've gone through our motor controllers and how we can manage those. We're now going through brushless and brush motors. Now we're starting to get to how do we monitor peak amperage so that we don't exceed our magic number.
That's pretty important stuff.
Make sense?
Especially with brushless motors. you can really ruin your battery.
Bingo. So, I can do a lot of funky things, but my motors on my drivetrain, I have potentially max breakers of 40, 20, and 10, right? Those are my options? Yeah, I think it's, my breakers are 40, 20, and 10. Those are my options of the PDA.
I think, well, there are 2 sections on the PDH. There's one for smaller things like our sensors, and those are, I think 5, 10, and 15. And the major breakers are 15 and 20. Yeah, and 40.
So on top of that, I have breakers here that further limit me. So now, where I could pull this crazy number, I might really be only at 40 and 20 based on my breakers. And so 40 times 4 is going to be 160, and I might put some 30s there, and maybe I can put 20s. And this will be 40. So now I'm at 80. And so for my drivetrain alone, I'm at 240. Still not useful, because can I do anything else with my robot at that point? Can I just drive? This needs power. This needs power. This takes up, I'm gonna say, let's say 1 amp. I'm just making these up. This takes up maybe 3 amps. I'm just again making this up. This Raspberry Pi takes up another 1 amp. This camera might take up 1 amp. This Ethernet switch might take 1 amp. This is being gross, but my RSL might take 1 amp. My pneumatic controller might consume 3 amps. My PDH will take 1 amp. So, do I really have 240 volts to play with? Or 240 amps to play with?
No.
No. I'm going to have to minus 1, 2, 5, 6, 9, 10, 11, 12. So, really, I've only got 228. And do I want to get close to that? What happens if I get close to that?
You won't be able to power anything else.
What was the brownout thing again? Yeah, I think this drops below like a certain amperage, it turns off, and then it turns back on, and the whole robot is reset for 30 seconds. So what happens to your soul?
It dies.
It falls out your way. So we might want to say, hey, let's put a buffer in there and say we don't want to go anywhere near. We don't want to go over 200. Make sense? In which case, does this work for my drivetrain? No, I have to break this down now. So I might want to limit this to 10 with software. And I might want to limit this to 30 with software. So that'll get me 40 plus 120, so 160, and that gives me 40 amps for everything else. Now, this might be enough for my robot if I don't have to do anything else while I'm driving. What's one thing I'm almost guaranteed to do while I'm driving?
For McLean,
For any robot, just about.
steer.
Steering's already included. You got your turning motors. Alright, Mom's here. Alright, take the three of them and take the homework book. Alright, Mom's here, guys. Love you. I'll see you at home. What else do I want to do? What am I constantly trying to do if I don't have a game piece?
Find one or get one.
Right? I got roller intakes, right? How many motors in my intake? What do you guys want? One or two?
Two.
Two motors? How many amps do I want to put on them?
Like 10, 20.
Max I can put is 20 apiece. Let's just be 10 with software. So now I'm at 180. Make sense? Now, let's say I want to intake and convey. One conveyor mode.
But then just stop and go.
Right?
After you intake.
I want to shoot while I'm moving. And I need lots of power for my shooters. So now I'm at another 10, which is 190, and then another 60, which is, I'm over 200. So now I gotta play this whole game again, right? How much do I want to dedicate to these things? And why do I now want to go over 200?
Because then the reel might shut down.
I run the risk of having my soul fall out of my chute. Yeah? Alright. That's power, everybody. You made it through one of the three systems so far. This is called a budget. We're going to put one together every year. The other thing I would point out with power is each one of the ports on these various systems is numbered. We have to put a wiring diagram for this year. One last thing for power.
How long does it usually take to diagram everything?
What do you mean?
Like, to make this whole thing?
We have to decide how many motors we want, and that usually takes a while for us to decide how many things we're gonna do based on the beam. We have a general diagram, and it usually takes like 2 to 3 days to flash it out.
If I have a 40 amp breaker on something in my PDH, can I put 22 gauge wire on it? Can I put 18 gauge wire?
Are you looking at what?
Yeah.
For a big breaker, you want big wire. Obviously, it's gonna be more power going through it, so you don't want a small gauge. Or the way wire gauge works is as it gets smaller, the numbers get smaller because it's that percent of an inch. Does that make any sense?
Gauge?
So what would be larger, a 6 gauge or an 18 gauge?
6.
And why is that? Think of how much fractions.
So, this wire is made up of little pieces of copper.
Oh.
Each one of those copper electrons, or molecules, is an impediment to me getting through. Now these copper molecules are not super well spaced. So my electrons, which are smaller, can get through these copper molecules pretty easily. But in this one,
Well, it's how well spaced.
I have less empty space. And in this one, I have less empty space. And then when I get here, I've got less empty space as a percentage of diameter. Every time my electron runs into one of these things, what does it turn into?
Heat.
Yeah. And if I try to put too much power through something and it's constantly running, and the electrons are constantly running into the copper molecules, what happens?
Melts.
So someone asked if I had fire before, the answer was no, but we did smoke a wire because we put the wrong gauge on our power. So every time I put a very specific breaker in here, I have to also have the exact wire. If not, I can start a fire.
So, if something requires like 18 gauge, would it be okay to put a 12 gauge, or would that also?
Yeah, you can go bigger. Then what are you doing in your robot?
Giving you more sand, more power?
Any ideas? If I constantly use 12 gauge where I could have used 18 gauge, what have I done to my robot?
Weight it down.
I have added weight for no reason whatsoever.
Oh,
Is copper heavy or light?
heavy.
Heck yeah! Why would I want to add more copper to my robot than I absolutely need? Are these gauges designed to protect the robot?
No.
What are these gauges designed to protect? The wires. What are these breakers designed to protect?
The robot.
The wires. The weakest link in our entire electrical system is a bad connection. Why? Because let's say I have a great connection and my electrical team has taught you how to do connectors, and you will learn how to do connectors. And you do a great connector and you've got 100% splice. Awesome. But let's say you do a really crappy connector and I only use this percentage of my wire between the splice and the connector. What's happening to that location?
It's getting used to. Oh.
And that's why this breaker is here, because it's going to be like, ah! Stop letting electricity through because this is going to break, it's overheating. Make sense? And that goes to be why you have to do good connections, and we're going to teach you how to do that in the channel. All right, we're done with power. Woo! Did you guys think it was this complex? Just the power?
Yeah.
All right, so now the next system is what? Where does all the control stuff from? All right, so control needs to get signals to the Ethernet switch via Ethernet. Ethernet switch needs to get control to the radio via Ethernet. Make sense? Strangely enough, I don't actually have control for the RSL because the control is here.
There's a built-in control inside.
Yeah.
They're designed for FRC, so they know we need that.
So we've got that additional control actually built into the radio.
Very good.
My pneumatic controller, I need to get control to. My 5-volt power system, I don't think I need to get power control to. There's nothing to control. My camera, absolutely need a control to. Now I can get control to one of a few ways. I can get it to the Rio, or I can get it to the Ethernet switch. Make sense? What's the difference? Alright. I definitely need to get control to my Raspberry Pi, and I'll get that via my Ethernet switch. And now I need to get control to my motor controllers. Now I could run 3 sets of wires, one to each motor controller, right? Make sense? Like if I hooked a string to the 3 of you, and I want you to turn on, you turn on, you start swinging your arms. You turn on, you start swinging your arms. You turn on, start swinging your arms. Right? Or, I could give each one of these motor controllers an address and call you 1, call you 2, and call you 3. And send a signal down the wire that connects to all 3 of you and say, hey 1, start swinging your arms. Hey, 3, start swinging your arms. 2, start swinging your arms.
Advocating on it.
What does that help me with? Yeah, it reduces the amount of cabling I need to do, right? But it also creates a what? A weakness. Because if that cable breaks, what happens to all 3 of those motors? I'm allowed 2 CAN runs. CAN is the name for this control. And I think they go to motor controller, and then they end at the PDH. And I can run a second one that goes to this motor controller and ends at the PDH. All that does is now, remember, I have 8 motors in my drivetrain alone. Might I want all 8 of those on the same CAN bus?
No.
Yeah. If one goes down, I can't really use a swerve anyways. And then relieves me to use the other ones for all the rest of my intake and conveyance and shooter and whatever else I need motors for, right? Yeah?
But when you do something like that, does it split the power evenly throughout them, or does the first one get more power than the second one?
That's what the motor controllers do.
Yeah, so remember I said we have 200 amps? And you've got, if we went back to the battery, positive and negative, I only have so much oomph to push out of this battery. I can only push so much amperage at any one time. So if I'm running one motor, and let's say it's not limited, it's getting 100% of my amperage. Great. The second I add a second motor, they're all in parallel. Or series. No, they're all in parallel. Technically, no, they're all in series. No, they're in parallel.
That's what's, no, serious.
That's the PDH. The PDH.
Are they all directly connected or just stating that they're all?
Nonetheless, the PDH.
Parallel is when there are 2 wires from the input both going to each of the things individually. Series is if they were connected through each other.
Yeah, they're not connected sequentially. It's all in parallel. These 2 motors in parallel are just giant resistors, really. And have you guys learned what happens to resistors in parallel? No, it doesn't explain. Hundred percent of the power in this battery is divided by 2. Make sense? So now, with this, let's say this motor had 5,000 RPM when it was by itself, it might now only have 4,000 RPM. I'm not saying it's that drastic, but, and this one has 4,000 RPM. If I had a third motor, now they might all go to 3,800. A fourth motor, they might go to 3,600. So your question is sort of true. The more motors are added to the system, the less efficient, the less power goes to each motor. Really. Because I have a limited chemical energy source for electrons. It only has so much to push. Now, if this was hooked up to your house, it would still happen, but it would be almost negative. It might be talking like thousands of percent. I don't know. Do you know what the average drop is across, let's say, 2 motors in FRC? I've never.
Absolutely not. You don't want to hit that fail case at all. So I don't really concern myself with.
Yeah, I'm not sure what
how
that
bad it is.
number. It's not nothing. It's not horrible. But the more motors you add, the more you'll notice. Like if your drivetrain, when it was just your drivetrain with 100 pounds of weight on it, and the battery, you might be able to go 15 feet per second. But once I put all the extra weight on it and the other motors, or let's say it's still 100 pounds of weight on it, but extra motors are running, I might only be able to go like 14 feet per second. Make sense? All right. So CAN bus allows me to address and control things with one set of wires. Make sense? Ethernet allows me to do the exact same thing through this Ethernet switch. So now I can connect multiple devices via one port on my reel. And everything's addressed via, do you guys know what TCP is?
Yes, the transmission protocol. It just basically gets packets in order and gets and resend packets sent to the
What's critical in a TCP system, TCP network?
accuracy.
IP addresses. Yeah. It's the same thing as CAN bus. Here, you're gonna give each motor controller an ID, and it's only gonna listen to messages with that ID in that header, in the header of the message. And in Ethernet, you're gonna do the same thing. You're gonna send it to a specific IP address, whether it's the camera, the Ethernet switch, the PI, the radio, or the reader. Same thing. Make sense? All right. Where you plug things in is important. So you'll also have to monitor the ports and get those to software. Because if they're gonna send a signal via this CAN wire, they have to send it via the right port. So power, I need to make it so I have the right breakers, and I have organization, so if I ever have to troubleshoot, I can pull the right power cord. In control, if I don't use the right ports, the signal never gets sent. But let's say there's 10 ports here, and it's constantly trying to send to port 10, nothing's plugged into port 10. That robot doesn't know anything's going on. It's like, I sent it again. Right? Like if you started dialing your best friend's phone number, but got it wrong every time, would you talk to your best friend? Would she know you were even calling her? And you'd be like, why aren't you working? Answer the phone! Same thing. Make sense? All right, so that's control.
One more version of this type of we need to know what each thing's IP addresses.
Yeah.
Do you guys?
You electrical won't need to know that, but software will.
We'll need to know the IDs of each of them parts,
Motor controllers you will,
yes.
not the IP address. You electrical don't need to know this, as far as I'm aware.
Oh, the IP address.
Those will all get signed by software. But you do have to make sure that it's wired properly.
We have to communicate with them.
Yeah. All right, so last one is feedback. What on here provides that does something that might need feedback? Motors. Now I can put, so types of sensors. I've got touch sensors. What do you think those do? I've been touched. Send a signal. I've got encoders. What do those do?
Encode stuff.
Sorta.
What are they encoding? If all of our motors need one, what are they encoding?
So how fast is it?
They can measure rotation. They can measure, are you rotating? How much have you rotated? How fast are you rotating? And if I do absolute encoders, I can also measure where did I start from and how far away am I from starting. Even if I've gone around 10,000 times, I can still tell you I've gone around 10,000 times from start. Make sense? I've got Hall effect sensors. What are those? You guys know what Hall effect sensors are? You guys know who a scientist? I don't know what Hall's first name was. You guys know what magnetism is? If I have two magnets and they're close to each other, they don't have to be touching. But if they're close and I sense the magnetic field of one in the other, Hall effect. It's almost the exact same thing as a touch, but without touching. Make sense? I can have motion sensors. I can have distance sensors. Distance sensors, I can have different types. I can have IR, I can have LiDAR, I can have ultrasonic.
Those are
No, we can afford all three of those. You can get these sensors. You can get cheap versions of IR and ultrasonic. Roughly, I don't know, 50 cents, $1.
You can get a cheap enough
LiDAR, the cheapest one you can get is about $2.50.
Yeah.
Motion, I can do motion, I can just do like, did something cross me? I also have beam brake. Who here has a garage door? of sensor do you think you have on your garage?
It's one that's into like what, a laser sort of effect.
I've been broken! Something
Oh,
got
right.
between me and my reflector. Stop! Don't crush the child. Make sense? Steam brake. Why, did we use one last year on this robot?
I don't think so. Did we?
Oh, and this one?
We used an IR sensor, an IR distance sensor.
Oh, we did do one to know when the game pieces were inside the intake system.
Let's see. Can my camera be a sensor?
Yeah, it's in there since we.
What can I do with my camera?
Utilize and detect.
I can detect shapes,
Measure,
You can scan
This is-
little,
colors,
light,
distance,
amount of light.
light. I can detect patterns like April tags.
that we
So can you detect temperature?
Mm.
I mean, with
That's an infrared sensor.
Not, yeah, probably not with a visual camera, but
Yeah.
thermal, absolutely, IR.
I didn't get out.
Let's see, what others, color sensor. I can have just a
That's
straight
like
up
$200.
color sensor.
That's one.
What other types of sensors might we use on an FRC robot?
Limit switch.
Touch sensor. Anybody else? So I can hook any of these up and provide that feedback to the Rio directly. In some instances, I can hook that up to the motor controller. Why would I want to potentially hook it up to the motor controller as opposed to the Rio?
It has a more direct relationship with the motor.
So let's say I have an encoder here on this motor. I can tell this motor control via the CAN spin at 500 RPM. If this is detecting my RPM, I can feed that back to this, and then this adjusts that motor appropriately until this encoder says 500 RPM. Shorter signal. I might need less wire. I might need to have a lot less wire depending on where that motor is. Whereas if I have to get the sensor all the way back to the Rio, I then have to go back into the CAN, back to this motor controller, back to this motor, back to the sensor, back to the Rio, back to this CAN, and much longer loop. More steps. What does that mean?
Less efficiency.
You guys know what latency is? That's it. Yeah?
For if we can go and just connect the sensors we need directly to the motor controller, why would you ever just send it straight back to the Rio and then back to the motor controller if you could go?
Let's say it's two motors. Which motor do I send it to?
You need an import.
In some instances it makes sense, in some other instances it doesn't make sense. I could have a touch sensor on a specific motor if I want to extend something. Extend till I hit a touch sensor, great, stop. That way the commands from the Rio here can do some, do you guys understand what distributor edge compute is? You guys know what that term means?
Put their phones away.
That's all right. Edge compute is when I'm computing at the edge. You guys have heard of skeletal reflexes? What are they?
You're taking notes, Brian. Are you?
Huh? Sort of, but what's your lungs doing?
Breathing.
Yeah, is your brain sending the signal to your lungs to breathe all the time?
Right now, yeah.
It's involuntary.
I mean, it just does. You don't have to think about it.
Yeah, it just says continue breathing. And then the lungs sort of operate on their own, the heart's that way too, there's some edge compute. It doesn't always need a signal from the brain.
Yeah, it's like muscle memory.
Edge compute is helpful because I can distribute it to my motor controllers because we use digital motor controllers that have some compute power in them. So sometimes it makes sense, sometimes it doesn't. Edge compute is great because it distributes the computing, leaves my Rio freed up to do more processing. We use a type of camera called a, what's it called again? Limelight. That has edge compute in it. It can do some of the things on itself. Pattern, distance, shape, all on the inside of the camera before it sends the signal. So now what can I do? As opposed to saying to the Rio, hey, do this compute on this image, so I have to send this image to the Rio, I can keep the image in my camera and just give you the output, the metrics that I need for the Rio to make the next decision. Make sense? So, What are the three systems in an electrical system?
Feedback,
Feedback, yeah.
power,
Feedback,
and
power control.
control.
Do I want to use all of my battery?
Nope.
Do I want to absolutely manage my budget?
Yes.
Do I size wires based on my breakers?
Yes.
Do I want wires that are larger than they need to be?
No.
When is the most dangerous time from an amperage perspective? What actions are taking place in my robot? What am I spinning up?
The motor.
I am starting my motors from zero, in mass, like driving or turning. Did I remember the spike in the brushless motor versus in the brushless motor versus the brushed? We have to, limit our amperage via software so that we don't pull more amperage than we can handle. What happens if we pull more amperage than we can handle? Our soul falls out of our shoe. Right? Any other questions about the electrical system? So let's come over to this robot and see if we can't identify some of the things on this robot. You guys can take it off real quick. You take the robot off the cart. On the count of three. Up, down, and hold on. Before you do that, just make sure that the bumpers are actually fastened on.
Yeah,
That way you don't, there's one wing nut on. I don't see any other ones,
Not on this
so
side.
don't lift by the
JJ,
bumpers.
why are you taking the bumpers off?
I'm not, I'm trying to.
It's only on with one wing nut, they just
Yeah.
lifted by the bumpers, which scared the crap out of me.
Did you do the safety
No, I was
training?
grabbing-
Yeah. Why are you touching the robot?
Alright,
I'm about to
what's this thing?
Are you touching the robot?
the light thing, I forgot what it's called.
RSL.
RSL.
What's this thing?
The radio.
Good. What is that thing, the big gray thing in the middle?
Rio.
Cool. What is this gray thing?
Motor.
Right here.
Motor.
What's this one?
Or some motor.
JJ, what's the
Like the
electrical
smaller,
system
the smaller
on the
one, the next region.
If you wanna.
We'll get there.
No motor.
What's that?
Not even in this.
Motor.
What's this thing?
Motor.
What's this?
Motor.
What's this little sensor right here?
It's a IR sensor.
IR sensor.
No, it's the block one, the
Beam brake.
green brake.
What is this sensor right here?
No, it's a
Move your head. Down, big head boy.
is it an RPM motor?
It's an absolute encoder. Let's see. What's this thing?
Breaker. The on and off switch.
Yep.
Breaker.
Let's see. What else is on here?
Breaker's on the other
What's this thing?
Wires.
In a
Treads?
cable chain. If something moves on your robot and wires need to move with it, do you just let your wires move
Yes.
willy-nilly?
No.
What's this thing?
Protective.
Of what?
Gold. Plastic.
Yeah. What's all this really horrible looking red tape on here for?
JJ, when I made the photo black and white, you couldn't see any of it, and it looked nice.
What is this
We're
for?
just gonna post photos of it
It's
in
for
all black and white.
style and.
It's for protecting wires that should have been inside the tube.
It seems like an electrical issue.
Why do we
It's
want,
not.
but honestly, this is, joking aside, why do we want our wires extremely protected?
Because
Because
why they
that-
build a fast
yeah.
robot? Didn't one of them like shear off last year?
One of
Yeah.
them got sliced by
Yeah.
another robot.
We lose functionality if we lose access to our feedback. We lose functionality if our control goes down. And we lose
Blair.
partial functionality if power is cut off to a specific location, right?
And now we're getting shocked from this.
Not good.
That's not what we're getting shocked.
And if that camera is our primary feedback mechanism for shooting, do we shoot?
No.
No. If this CAN wire is connected to all the motors on the top of the robot, what happens to those motors that are beyond the brake?
They don't work.
None of them work, actually. So we lose everything on that CAN bus.
Oh, great.
So why do we want to protect our wires?
So things work.
Oh, yeah. Oh, another reason, or another way we protect them, if you wanna flip it over.
Yep.
Oh, the play at the bottom.
It's not there.
Is everybody on that side now?
Should
But
I-
you
should-
see
I'm
the
pretty
Velcro
sure
on the
it's
sides?
outside.
Okay, well,
Should I grab the
I don't know
plate?
where any of this stuff.
I'm gonna grab
Usually, you see all that Velcro, we usually have a panel attached to keep it all contained.
What's that gray thing?
What is that great thing?
Is it radio? No. Oh, it's the
Prevention.
No, it's I can't see the name from here. The thing that you can connect multiple motors to? Or no?
That's
Ethernet
like
switch.
motors. Yeah,
That's your Ethernet switch.
you need a lot of connections to different parts.
What's this thing then?
Raspberry Pi.
Why
Raspberry
is it
Pi.
all
4B.
Here's one of those motor controllers we talked about. Now, there's something under here. Somebody asked very early on about an IMU. That's a sensor I should have put up on the board. Do you guys know what an IMU does? It's got 3 accelerometers, so it can measure acceleration in the X, Y, and the Z. It has 3 gyros, so it
yeah.
can measure rotation around the X, Y, and Z. And it has a gyro, usually a solid state gyro, to, if I said it started in this position in this orientation, this little IMU says based on all the accelerations and gyro measurements I've calculated, you should be this distance away from your starting point in this orientation relative to your starting orientation. It will drift over time, meaning its error will increase the longer it is away from reset. One of the powerful things that we can do on this robot with April tags is with the camera, we can detect our position on the field and reset our IMU. Does that make sense?
What is the blue thing?
Which blue thing?
The rolls?
These? These are parts of the intake.
JJ, is when you reset that just field oriented?
Yes, but if every time I see an April tag, I reset, how accurate is my IMU? Very accurate.
Is the IMU connected to the Raspberry Pi or is it connected to the Rio?
It is connected to the CAN bus. The pigeon. What's this thing?
Breaker.
Well, that's a breaker, but what's this whole type of thing?
PTH.
PDH. Let's see. What's this thing?
Let's see.
Starts with a V. The acronym does.
Oh, what's the acronym again?
VRM.
VRM. That's what it was. I didn't hear you before.
Regulation module.
Voltage regulation module. That gets us down to 5 volts. Let's see what else is on the bottom here. See these green and yellow wires?
Yeah.
What are those?
Motor wires?
CAN bus.
1 second. Do you guys know why we would need a VRM for our robot?
Because some things can't handle like a lot of voltage, like the Raspberry Pi.
Can't handle them, and also we don't need to be pushing out extra voltage to them. So a lot of our sensors run on lower voltage just because it's obviously a lower power system. And we have quite a few sensors, as you guys saw. Also our radio is connected to that.
Cool. So that's the electrical system, the most important system in our robot. You guys got an overview. This is by no means going to make you an expert. She's going to have, and the electrical team is going to have some exercises for you in the later part of this year. You're going to learn how to make wires. You're going to learn how to connect things, and you're going to help wire a robot back up. Was it Corb you said?
Yeah.
So you're going to get a lot of hands-on experience. Right now, this is just an overview to give you the basics. Now you understand electrical system, how complex it is, and you can go on to websites and type in FRC electrical system, and you can see pretty much the diagram I drew up on the board. They'll have prettier colors and identify black and white for power, green and yellow for control, and then I don't know what they use for feedback. Make sense? Awesome. Any questions?
If you guys have any questions that you think of after you leave today, you can always send me a message on this.
Yeah.
Okay.
Discord, you could throw your research on there. If you want to go do something extra, you can ask questions.
Or if you want it with a broader, more, I don't know, experienced audience, you can just type an email electrical channel on the Discord as well.